Welcome to another episode of Medicine 3.0, your podcast for AI in medicine, precision medicine. This week, I'm so excited. I've got Dr. Bill Evans. He's a PhD from UC Berkeley. He's also an adjunct professor at Duke, and he studies muscle mass. And that might not sound that interesting to you, but it's fascinating to me because it's really hard to measure. And he came up with a new way to measure muscle mass with a urine test. It's more accurate than a DEXA scan or an MRI or CT scan, than really any kind of test. And we talk all about how to maintain your muscle, how to have stronger muscle, and really think about muscle as you age. So this goes a little bit in the weeds here and there, but I think you're really going to enjoy this. All right, Bill, welcome to the podcast.
It's great to be here. I'm looking forward to this conversation.
Awesome. Well, so am I. So let's start off with my favorite question. Where did you get where you're at knowing what you know?
Sure. Okay. Well, I'm currently a professor of human nutrition at University of California, Berkeley. And I also have an adjunct appointment at Duke University in the geriatrics program. So, I did my graduate work at a place called Ball State University, which has a terrific, at the time, the best kind of exercise physiology lab. And I left there, and my initial faculty position was at Boston University. At the same time, I did a postdoc at MIT in the nutrition department with a terrific investigator named Vernon Young, who was maybe the dean of protein metabolism in the world. And through that work, I was very lucky to be one of the initial lab directors of a brand new facility in downtown Boston called the USDA Human Nutrition Research Center on Aging. And, 4 years out of my PhD, I was now a lab director at this brand new $40 million facility in downtown Boston, designed very specifically to understand and look at the nutritional needs of older people. My lab was we called it the Human Physiology Lab, and what we did was explored the interaction between physical activity and dietary needs, including energy and protein. And of course, our laboratory focused on muscle, and that's where the term sarcopenia came from. That is, it was just striking that in any way that we could measure it, lean mass or muscle cross-sectional area, or however we looked at it, older people had less of it than younger people. And so, my idea was at the time that this loss of muscle would predict, some later outcome. Muscle is so important to not just how we move, but how we metabolize glucose and fats and our energy metabolism, that it would ultimately predict late life outcomes. And it's been a long road, but it certainly appears as though sarcopenia is a term that has been used. There's almost 12,000 references to it in the scientific literature. And yet, it is maybe one of the most important aspects of aging, and that it affects almost everything that happens to us as we grow older, including the risk of losing our independence. And yet, it's a condition that has not been recognized by the FDA. And as a result of that, there is very little medical attention that's paid to sarcopenia. And, we can talk about sort of why that is. My take on it is that, at the time that we came up with this term, which was fairly simple, sarcopenia is defined as the age-related loss of muscle. There really wasn't a way to measure how much muscle is in the body. And that has been an enormous problem in the field. And Most investigators that attempt to look at sarcopenia have used estimates of what we call lean body mass or fat-free mass. Now, on the face of it, that would seem like a logical way to do it. That is, fat-free mass must be muscle. But it turns out that there's a lot of other stuff in fat-free mass besides muscle. And in fact, among older people, muscle is only half of fat-free mass. And it turns out that the measurements of fat-free mass that have been done in thousands and thousands of older people don't predict outcomes. The surprising thing about all of the research in sarcopenia has been that this surrogate measurement of muscle, which is fat-free mass or lean body mass, is unrelated to outcomes. It's unrelated to the risk of disability. It's unrelated to risk of falling down. And it's even not that closely related to functional capacity. And so it's led to most investigators who use these measurements to say, well, the amount of muscle that you have is probably not very important. There's got to be some other aspect of aging that affects muscles, some intrinsic quality of muscle that must lead to these changes in outcomes. And so that's where the field has been. And as a result, there have been maybe 15 different published definitions of sarcopenia. And they started out with the use of fat-free mass plus strength and plus some other measurements. And then it turned out that probably strength, how strong you are, was a better predictor of outcomes than fat-free mass. And so the newer definitions included no measurement of the amount of muscle or fat-free mass, but only strength. So there's been this problem in the field, and so my colleague and I decided that we have to have some way to measure how much muscle is in the body. There are a couple of ways. You can do MRIs, magnetic resonance images of the whole body, but they're very expensive, and it would be tough to do in 2,000 people if you're doing a cohort study. So we invented what's called the D3 creatine dilution method, and it's fairly simple. The idea here is that virtually all of the creatine in your body, about 98% of the creatine in your whole body, is in muscle. And that's because creatine serves in a very critical aspect of muscle metabolism. Creatine is converted into what's called creatine phosphate, high energy compound in the muscle. And so when you need to use your muscles immediately, if you're walking across the street and someone honks their horn at you and you have to jump out of the way, you're using creatine phosphate as a fuel. And so it's really critical. And so all the creatine in our bodies, with some small exceptions, are in muscle. And muscle doesn't make creatine, it's made in the liver and the kidney, and then it's pumped into the muscle against a large concentration gradient. So our idea was that we would use what we call a stable isotope label. We put a heavy hydrogen on the creatine molecule. And we can give that in very small tracer quantities. In adults, we use 30 milligrams of deuterated creatine, which is just less than 3% of the amount of creatine that's in a hamburger, for example. It's a very small amount. It's then transported to all muscles in the body. And then the beauty of this compound, creatine, is that it's converted into a compound with the same molecular weight called creatinine and lost in the urine. So, and we've long known that creatinine levels in the urine are a rough approximation of how much muscle you have. In fact, there was a test that we've used in the past and other people have used. That is, you measure the total amount of creatinine that's excreted from the body in 24 hours, and you can estimate how much muscle you have. So the idea here is that we can sample urine and look at the amount of hydrogen in the creatinine and then predict how much creatine is in the body. And from that, we can calculate how much muscle you have. So it's a long way of saying we have a completely non-invasive, accurate, and direct measurement of muscle mass using this small capsule that is, we've measured it now in premature infants, some as small as 2 kilograms. We've looked at them while they're in the neonatal ICU. We've measured it in now almost 4,000 older people. And then for the first time, we can, in fact, say and determine how does muscle affect outcomes. So for the first time, we can say that, yeah, it's pretty important. And when we compare our measurement against the typical fat-free mass measurement, we find that our measurement, this measurement, is highly associated with functional status, but outcomes like risk of disability. And not just disability like your ability to climb stairs, but what's also called instrumental activities of daily living. And that's things like your ability to balance your checkbook. So muscle appears to be related to changes in cognitive function, but it's also related to risk of falling, risk of hip fracture, and risk of all-cause mortality. So now we've incorporated this method into the Framingham study. So it's incorporated into what's called the Women's Healthcare Initiative study. So we have thousands of older women who are now in this study. We have a large longitudinal study called the Study on Muscle Mobility and Aging, and thousands of older people. We've just recently completed a large multi-center trial in boys with Duchenne muscular dystrophy, and we can talk a little bit about that as well. So for the first time in muscular dystrophy, we can measure how much muscle these boys have and how it progresses over time. So we have, again, a non-invasive tool to assess disease progression in this terrible disease. And so it's been an exciting time for us now. So we really are starting to understand the importance of muscle. And that's not to say that there aren't changes in the intrinsic quality of muscle, because we know that there are. For example, muscle with advancing age, it gets more fibrotic. There's more scar tissue in muscle. It has more fat in it. But until we understand what the effect of the amount of muscle is, which we now understand, it's more difficult to say what the effect of these other factors are. So I think that we can begin to separate all of the various factors associated with muscle that also includes the total amount of muscle that you have.
You know, it's fascinating. You talked about so many different things, but one thing that I've kind of been stuck on for the last several years is the idea that muscle is kind of the currency of aging, that it likely is what keeps us moving and keeps us healthy. And at the same time, I've been stuck on the tools that we have for measuring muscle, because one of the things I'll often do is I'll have patients of mine do a body composition DEXA scan, and I'll calculate out their free their fat-free mass index and their appendicular lean mass index. But what I found is, honestly, it was on one of my first patients that I sent to get a DEXA, who was obese, and his fat-free mass index was super high and his appendicular lean mass index was super high. And what I realized right away was just how much fat must be stored in the muscles
Right.
for that to be true.
Right.
And so I kind of went in the same direction that you said the scientific community has gone. I went to, well, then we must rely on strength to
Right.
understand this. And it sounds like where's the community landed currently? It sounds like you've got a test now that we can reliably measure how much actual muscle somebody has, and there's this component of strength. But as physicians, as scientists think about aging community, where have we landed on figuring out somebody is sarcopenic or somebody is not sarcopenic? Is it based on both of those things? How are we measuring it
Oh,
now?
that's a terrific question, and I love your statement that muscle is the currency of aging. That's great, because I think it is. Of all of the things that are affected as we grow older, muscle affects everything. And it's remarkable to me that so little attention has been paid to it. We did a survey of docs, internal medicine, rehab docs, and geriatricians, just to ask them if they even know what sarcopenia is. And the only physicians who really kind of even understand that it's something are geriatricians. Even internists don't quite understand what that is. And where the community is going on this is a moving target. It's I and my colleague Luigi Ferrucci, who is the scientific director at the National Institute on Aging, wrote an editorial recently that sarcopenia should be defined only as the amount of functional muscle that you have. And the beauty of this test, so creatine is located in the muscle cell where the actin and myosin, where the cross-bridge formations occur. And that's natural because that's where the ATP works to cause muscle contraction. It's not in the other components of muscle. So we think that it's a measurement of not just muscle mass, but functional muscle mass. So I think the community is slowly coming around, but like everything, people have their beliefs and sometimes they die hard. I can tell you when we first started applying for grant applications from the National Institutes of Health, some of the comments were, "I don't believe it," And so we've moved beyond that. Even some of the reviewers that we had for our initial manuscripts were skeptical. But I think now our most recent grant applications, the reviewers have said, "Oh, this is a novel method and it's validated," and so I think that we're using it more and more. And we've just discussed with some venture people about rolling this test out for people like you, or people that, especially for docs that may be associated with wellness centers who may want to use a test like this for the people that are participating in these centers. And so hopefully within the next year, we will have a test that can be used by consumers and by docs. We're also, through another avenue, we're applying to the FDA to ultimately get approval to have this as a diagnostic test. The FDA is very clear about kind of what they would look at, and for us, it would be for older people that have a mobility disability. You as a doc would order the test and you could determine whether that mobility disability is due to low muscle mass or some other maybe neurologic problem or balance problem. And so that's how we're approaching it. We have data now that tell us that when an older man is 25% or less muscle, they either have or have an extremely high likelihood of a mobility disability.
Hmm.
And for women, it's about 20%. And what's interesting, we've just completed a study, as I said, in boys with Duchenne muscular dystrophy. And we had about 100 patients in this study from age 4 to 24. And so we looked, and as you might expect, or maybe not, muscle mass does decline as they grow older, when in fact, it should be going up. Between the ages of 24 and 24 should be going up. It doesn't. And we looked at those that were ambulant, those that could walk, and those that couldn't walk. And if we separate those two, we can see, for example, there's a clear difference in the amount of muscle, as you might expect. There's a statistical difference in age. The older ones can't walk and the younger ones can. But when we look at percentage of muscle, what's astonishing is we see a clear, maybe threshold at about 20% muscle, below which we see that they're non-ambulant and above which they are ambulant.
Hmm.
And so what that means is that potentially an important way of maintaining ambulant status is to keep the weight off. And that's extremely difficult in patients with Duchenne muscular dystrophy. By the time they're about 11 or 12 or 13, their physical activity levels are low enough that it's very difficult to maintain a constant weight. And they gain weight, and sometimes they gain a lot of weight.
Mm-hmm.
So our next strategy, we're just applying for grants, is to use a GLP-1 agonist in these patients because they have such a difficult time. You can imagine if you're completely sedentary. Food may be the only thing that you enjoy. And so maintaining a weight or losing weight in these patients may be an important way for them to maintain ambulant status. The same may be true for us as we grow older too. Is the percentage of muscle mass maybe certainly as important as the total amount that you have. So there's a lot of really interesting work going on right now, and the definition of sarcopenia will slowly change, I think. There are a lot of people that make a living out of defining sarcopenia, so
Yeah.
they will still continue to have their ideas about what it is, but I think things change, and what I tell my colleagues whenever they you get a bad review or a stupid statement, you just have to continue publishing. You just publish more data. That's the only way to answer people, I think.
Yeah, that's how science works,
Yeah,
right?
that's exactly right.
Keep looking for truth and finding answers and continuing down that path. I'm
Yeah.
curious, when you think about hard outcomes that we can look at and how people should remain self-motivated, because I think a lot of older people, so I have a mother in her 80s, and I'm constantly telling her she has a house with stairs, and I tell her you got to go up and down those stairs as many times as you can in a day, and then I'll call her and she'll say, well, I did it once this week or twice this week.
I
And
know.
I told her, well, you should plug your phone in the basement every day. And so, because I know you're going to get that phone. And so I'm curious, as you try to kind of inspire people to keep their muscle mass, what are the hard outcomes? You named, there are cognitive outcomes, decreased cognition with decreased muscle mass. You talked about falls and, mobility. Are there any other outcomes? I guess you said all-cause mortality is actually one of those outcomes. And how do those outcomes relate to other things? Is this a stronger indicator than fat or BMI? How strong of an indicator is it to have low muscle?
It's a really good question. So as you know, there is a term called sarcopenic obesity,
Hmm.
which in the past it means that there are people, older people, that have two things. They have low muscle mass and high fat levels. And the idea was that they work synergistically to make the outcomes even worse. Well, it turns out when we use our method and actually carefully and accurately measure muscle, the amount of fat that you have is not as important. It's the muscle itself. And in fact, the term sarcopenic obesity is kind of a term that doesn't really have any meaning, because it's even among obese people, it's the amount of muscle that they have that ultimately determines how functional they are. So the outcome, I think, because sarcopenia has become sort of almost a political word in the field, because everybody seems to think they understand what it is. Mobility disability is probably the best outcome measurement that we have. It's pretty simple to measurement right now. What's astonishing, and this is one of the other things that we strongly advocate for, is that you should have a test when your older patient comes in that you can perform and get reimbursed for from CMS. A gastroenterologist does, a cardiologist does. They have these procedures that they do to try to understand the state of that system in their patient, and they get reimbursed for doing the test. And we have tests, like a simple, what is your habitual walking speed, for example? Some people have called that, a vital sign, because it's so highly predictive of outcome among older people. You could do that. It's simple to do. Or ask your patient, how many chair stands can they do in 30 seconds? Simple but reproducible tests. And that would tell you as a doc, well, you're different than you were a year ago. And right now they don't know that. Unless you really carefully try to establish some sort of baseline functional measurement, what happens with many docs is they say, well, Mrs. Jones, how are you doing? Well, I'm doing all right. And that's the end of it. Unless someone is so debilitated, well, I can't climb stairs anymore. Well, we know we can do something about that, but if you intervened a little bit earlier, like your mother walking up and down stairs, we wouldn't have gotten there. And it's, as a doc, if you know how your patient is changing, and we even have, quality of life questionnaires that could be used for this, but there is no reimbursement strategy for that. And I think that really is a terrific way that we can kind of move the field forward. Something very, very simple. If your nurse could do a short physical performance battery test, or even a chair stand test on the patient before the patient comes in to see the doc, and get $100 for doing the test, well then, that would be great. But right now, nothing like that occurs, which I think is really awful.
I agree. That seems like such a simple thing to do. It really seems like an education problem for physicians. I think if physicians knew how predictive the test was, and they knew what it took to do it, they would most likely want to do it.
They would want to do it, but you and I both know that if they got paid to do
it, they would absolutely do it.
They would absolutely do it. And it doesn't have to be a lot, but if they got paid to do it, they would do it.
That's exactly right. That's exactly right. You mentioned that we know what to do if somebody's getting weak. And let's talk about, normal healthy patients, not with muscular dystrophy.
Sure.
So older healthy patients that are getting weak, and maybe they're even getting below that 20 or 25% of muscle, and we want to build muscle in them. We want to get them stronger. We know that stimulus matters. We know that they have to work. How much does nutrition matter? How much does, eating enough calories or eating the right kind of macronutrients? How much does that actually matter?
It matters. A couple of ways of answering that question. So, in an otherwise sedentary population, dietary protein intake is important. And inadequate protein intake leads to a loss of muscle. We did a study years ago where we very carefully controlled how much protein a group of healthy older people consumed. It was a 3-month-long nitrogen balance study. So we absolutely knew how much they were eating, and we gave them the recommended dietary allowance. And they lost muscle. They all lost, and we measured that by CT scan at the time. So we looked at the size of their muscle. And in 3 months, we saw a small loss, but it was a loss. Our conclusion was the RDA was inadequate to maintain muscle mass in otherwise healthy older people. And you would ask, well, why is that? Why would old people be different than young people? Because the RDA was really established in healthy young people and assumed to be the same as it would be for old people. But as you know, as we grow older, there are a lot of things that change that affect how muscle makes protein and how muscle is maintained. One of which is that we lose testosterone. Testosterone production goes down. Growth hormone production goes down. There's a paper just published this month that shows that estrogen levels in women may be highly associated with how muscle ages. So estrogen levels go down. So these important signals to muscle to make new protein are reduced. Muscle becomes more insulin resistant. And that means that the efficiency of making protein also goes down. And we become less physically active. So all of those factors mean that muscle in an otherwise healthy person who as they grow older, isn't as efficient at making protein. And that's really what sarcopenia is. So the next question is, what do we do about that? Well, one is eating more high quality protein. So the RDA is 0.8 grams of protein per kilogram body weight per day. I generally recommend almost double that, which we know is not dangerous. It doesn't have any effects on renal function if you have healthy kidneys. And it's not a huge amount of protein. So that can help maintain nitrogen balance. But the other part of it is that strength training, resistance exercise, we know, stimulates the muscle to make new protein. And it occurs whether you're 40, 60, 80, or 90. This remarkable effect of resistance exercise stimulates muscle to make new muscle. Mm-hmm. You know, we did a study years ago where we did resistance exercise in 90-year-old people. We took muscle biopsies, and we found the huge increase in what's called neonatal myosin. So it's a signal that brand new satellite cells are being mobilized, and new muscle cells are being mobilized, and protein is being stimulated, and you know, in 10 weeks, we were able to triple their strength. You know, it was really remarkable. And that kind of was the paper we published in the New England Journal, you know, more than 30 years ago, and maybe led to a lot of people thinking about resistance exercise as an important way of improving strength and functional status in older people. And again, as you know, we still don't have a drug that can stave off sarcopenia, although I think that there's a lot of renewed interest right now in this area. I think there'll be a lot of new potential drugs that are being developed in this space for a lot of important new reasons, and so I'm optimistic that combination of new pharmacologic therapies and certainly resistance exercise more than anything can help that.
I think that's such a hopeful message to send to the older population that it's never too late. I think sometimes we get the message that if you didn't start exercising young enough, then it's probably too late. And I think, you talking about these studies where we measured really old people that 10 weeks of resistance training tripled their strength and caused all this new muscle growth. I think that's so important. And then also the knowledge that you need the stimulus of lifting and you need enough protein to be able to build more muscle protein.
Yeah.
And that, I think that message just cannot be repeated enough.
What's interesting is that resistance exercise has a lot of effects, obviously, but it does make muscle even more efficient at making new protein, so that
Hmm.
in a person who may be eating a marginal amount of protein, resistance exercise makes it less marginal. It makes it um, more efficient at using the protein that you consume. So, in many ways, if you resistance exercise, you can maintain balance even on lower protein intakes. So, it's interesting.
Yeah, that's a great point. Yeah, you don't have to, maybe you can't afford as much protein as you should be able to eat to grow your protein. Or maybe you just, I know plenty of people that don't like to eat or drink protein,
Yeah,
but just doing resistance exercise, how
yeah,
important that is.
yep, yep, absolutely. So, yeah, I'm very optimistic that there is a whole new resurgence in muscle interest. And part of what's going on is the use of the so-called GLP-1 receptor agonists and Wegovy and tirzepatide that we know result in weight loss. I mean, it's maybe the I'm sure you've had a lot of discussion about this as well. Is that this new way that we have of causing weight loss? It works. It reduces the risk of cardiovascular disease. It's really incredible. But one of the things that we do know, and the pharma industry very, very interested in muscle, because weight loss always results in some loss of muscle, always. And in older people, it may be even more than it is in younger people. And so when you think about it, it's many older people um, are eating lower amounts of protein. They go on a GLP-1 agonist for weight loss. Their energy intake goes down. Their protein intake goes way down, and they appear to lose an exaggerated amount of lean mass or muscle, and that's a worry. Many of the drug companies are interested in maybe an agent that will preserve that muscle mass. Lilly spent $2 billion on a drug called bimagrumab, which is a anti-myostatin sort of drug, very specifically to try to use it as an adjunct to weight loss to preserve muscle mass. So there's a lot of interest right now, and that may be where the new kind of revolution in new therapies for muscle will come from, because the FDA has signaled that they would be interested in approval of an agent like that as long as it results in some improvement in functional status in those patients. So there's a lot of new things that are going on. Some older potential drugs that are being kind of utilized now. So I think it's an exciting time.
Yeah, I'm curious, is any of the drug companies using your test to see if there's muscle preservation or how much, as we know, these other tests are inferior to actually knowing how much muscle is still around? Are any of them using your test?
Yeah, it's a good question, and some are and some aren't. We just received a colleague of mine at the University of Kansas and I wrote a grant application for the National Institutes of Health to use our test along with a GLP-1 agonist in older people to look at loss of muscle. We got a second percentile score on our NIH application. Every other circumstance that would be funded. So we're hopeful that we will, for the first time, because the study is designed to look at resistance exercise or no resistance exercise in a group of older people with obesity, and
Mhm.
we'll track changes in the amount of muscle that they have and in strength and function. And it's with my colleague John Jakizik, who has published a lot of really, really important papers on weight loss and functional status. So we're excited. We hope that NIH is still funding new studies, and if so, then we'll have the answer to that question pretty soon, pretty quickly.
Yeah, I feel like there are so many important questions. I mean, you even mentioned one, just, if you change somebody's weight, and they'll lose muscle, but if their percentage of muscle goes up compared to their total body weight, then do they get to a functional state?
Yeah,
And
yeah,
I think those are really important questions that we need to answer.
I absolutely agree with that, and I think that those questions will begin to be answered. I think that a lot of drug companies are starting to climb on board, especially new startups, newcos that are interested in weight loss and a drug that may help to preserve muscle mass. So I think over the next couple of years we'll see that. I mean, obviously the GLP-1 receptor agonists are $1 trillion industry right now, and any company that may have an edge over another company, if you can couple it with some other therapy. One of the other areas that we're looking at is use of essential amino acids to try to stimulate muscle protein during weight loss, and so there are a lot of interesting strategies right now that will do that, and there's nothing like this new remarkable thing that's on the horizon now that ultimately does result in weight loss. I think that
Hmm.
the concern mostly is with older people. I think that if younger people lose muscle and they lose weight, they'll ultimately gain it back. I think
Right.
it's the over 60 groups. I think that may have some problems.
Yeah. Yeah, I think you're right. I want to project into the future a year and say that people have an at-home test that they can use to track how much muscle they have, and then kind of project into the future how much muscle they need to keep to remain mobile or continue to reach their goals. You said the test includes a pill, a
Yeah,
urine test. Kind of explain what the procedure, so people can imagine what
yeah.
doing this test is like.
So the way it'll work is through your facility, the facility you work with. You think that you have 50 patients who may want to monitor their muscle mass. You order the kits, and the kit would be the pill. We have a urine sampling device, which is essentially a little plastic stick. You press a button, and a filter paper comes out. You either urinate on the filter paper or dip it in urine, retract it, put it in your freezer. You then mail it to a central lab. The lab does the analysis and then gives you the data. And so that the information that would be provided then is what is your muscle mass, what's your percent muscle mass, and where is it in relation to your age and sex.
Hmm.
So we have those data, and we're collecting more and more of those data every single day. We're doing thousands of tests every day now, and we'll be able to tell someone what their score is, what the average muscle mass is, and where they fit above or below that. And then based on the literature, we can know what the risk is for too low a muscle mass,
Yep.
and what strategies you, as the doc, may want to employ for your patient, or what the patient may want to do right now, because, as I said, there's no pharmacologic intervention, and so everything, stuff that you can do at home.
Yeah.
So there's a lot of ways of getting that. Our hope is that this test will get out there pretty quickly, we're just starting to raise money to get the tests up and out and going, and hopefully within 6 or 7 months we'll have it available.
Awesome. I think that's extremely exciting. I think, um, knowledge is power. And I think the more that we know our bodies and we know our trajectory, the more we're able to intervene and help ourselves be
But
healthier.
I go back to your fantastic statement, is that muscle is the currency of aging. I think that's absolutely true, and more
Mhm.
so than any other single thing that you can measure. And all the other stuff, insulin sensitivity. We just published some data that shows that in older people, the amount of muscle that you have is strongly related to your insulin sensitivity, just the amount of muscle that you have. So all of these factors are associated with muscle. And the other one, cognitive function. We know that risk of Alzheimer's disease is strongly related to diabetes and poor insulin action. But the other thing that it's really associated with is physical activity. In fact, there's probably very few things that you can do that help to preserve cognitive function and memory more than just going out for a walk.
Yeah. And I think those are the great takeaways from this discussion, is that people have the power to change their lives, change their bodies by being active, and that in the not too distant future, you're going to be able to track it, and it's going to be easy to track. So,
Yeah.
Bill, thank you so much for your time, for
Thanks,
the
Jared.
discussion. This is fascinating. Thank you for your work.
Absolutely. I appreciate it. And good luck to you.
Thank you.
Thanks.
Thank you for listening to another episode of Medicine 3.0. We make this podcast so that you know where to turn for good information on keeping you and your loved ones healthy. Feel free to check us out at bionichealth.com, where we can help you live a longer, happier life.